In the early 19th century, the field of paleontology was still in its infancy, with scientists eagerly scouring the Earth for remnants of ancient life. During this time, the discovery of a massive set of bones in Louisiana, USA, would set off a chain of confusion, intrigue, and eventually groundbreaking revelations. It all began in 1834, when a group of paleontologists stumbled upon a vast spread of fossils unlike anything they had ever seen. These remains, sprawled across an area the size of a soccer field, included huge vertebrae and various skeletal parts that hinted at the existence of a creature beyond their imagination. The size and shape of the bones immediately captured the interest of scientists. The vertebrae were immense, indicating a creature that must have been incredibly long, perhaps stretching over 100 feet. At a time when knowledge of ancient marine life was limited and no extinct whales had been recognized, the natural assumption was that this was the skeleton of a massive marine reptile. This assumption was partly due to the creature's long, narrow body, which seemed more akin to a snake or a mosasaur, one of the formidable marine reptiles of the Cretaceous period. Paleontologists named this creature Basilosaurus, which translates to king lizard, a title that reflected both its size and its presumed reptilian nature. Despite its name, the classification was deeply flawed. The elongated shape of its bones, combined with its unusual size, led to an assumption that the creature was a giant sea monster. To the scientists of the time, it seemed implausible that such a massive, serpentine creature could be anything other than a colossal lizard prowling the ancient seas. Adding to the confusion, one notable naturalist, Albert Koch, went as far as reconstructing what he believed to be a complete skeleton of Basilosaurus. However, Koch's creation was not a true representation. Instead, it was a patchwork of several incomplete skeletons stitched together to create an exaggerated version of the creature. Koch even gave it a different name, Hydrakos, and claimed that this monstrous sea serpent was larger than a blue whale. His model drew significant public attention and fueled the misconception of Basilosaurus as a sea monster rather than a marine mammal. This sensationalized portrayal only deepened the misunderstanding of this ancient whale. It wasn't until later, after more fossils were found with teeth intact, that the pieces of the puzzle started to fall into place. The teeth were large and blade-like, resembling those of predatory whales that feed on fish. This realization was a breakthrough. Further analysis revealed that the teeth were not designed for crushing bones, as those of reptiles might be, but rather for slicing through flesh, a trait common to certain predatory whales. This crucial piece of evidence shifted the narrative, leading scientists to reconsider their previous assumptions. Gradually, as paleontologists compared Basilosaurus fossils with those of known cetaceans, it became clear that this creature wasn't a reptile at all, but a primitive whale. This revelation marked a turning point in understanding both the fossil itself and the evolutionary history of whales. The misclassification of Basilosaurus as a lizard and its subsequent reclassification as a whale highlighted the early challenges in identifying and interpreting ancient life. It also underscored the remarkable evolutionary journey of whales, as this once misunderstood creature became a key piece in the puzzle of how modern whales evolved from land-dwelling ancestors. When the true nature of Basilosaurus came to light, it reshaped not only scientific understanding, but also the broader narrative of whale evolution. It demonstrated how early whales transitioned from land to sea, adopting new and sometimes bizarre adaptations that enabled them to thrive in a completely aquatic environment. This period of scientific discovery and correction reflected the broader challenges that paleontologists faced in piecing together the history of life on Earth, especially when presented with creatures as enigmatic and otherworldly as Basilosaurus. Once identified as a whale, Basilosaurus took on an even more terrifying image. Unlike the gentle giants of today's oceans, this creature was a full-fledged apex predator, dominating the shallow, warm seas of the Eocene epoch. Standing at the top of the food chain, Basilosaurus was a formidable hunter with characteristics that set it apart from both its modern descendants and its ancient competitors. With an estimated length of up to 66 feet, 20 meters, for the largest species, Basilosaurus was one of the longest marine predators of its time. Despite its massive size, its body was streamlined and narrow, which allowed it to move through the water with surprising agility. This shape was unlike that of any modern whale, giving it a more serpentine appearance, reminiscent of the long-extinct mosasaurs. However, Basilosaurus was far more than just a relic of the past. It was a hypercarnivorous whale with a specialized set of tools that enabled it to thrive as the dominant predator. The jaws of Basilosaurus were equipped with a terrifying array of teeth. Unlike most modern whales, which have uniform peg-like teeth or baleen for filter feeding, Basilosaurus possessed a varied dental arrangement. Its canines were curved and sharp, designed to pierce and grip prey effectively. Meanwhile, its molars were massive and serrated, capable of slicing through the tough flesh and bones of its prey. This combination of canines and molars made Basilosaurus's mouth one of the most fearsome weapons in the ancient seas. The power of Basilosaurus's bite cannot be understated. Reconstructions and analysis of its jaw structure have revealed that the smaller species, Basilosaurus isis, could exert a biting force of up to 20,000 newtons, enough to easily crush the strongest bones in the human body multiple times over. This immense bite strength was a crucial asset, allowing it to take down not only large fish, but also other formidable marine predators. Evidence from fossilized remains shows that Basilosaurus fed on a variety of prey, including large bony fish, sharks, and even smaller whales within its family, such as Dorudon. These smaller whales, though still sizable at up to 16 feet, 5 meters, in length, were no match for the immense power and speed of Basilosaurus. Fossil evidence has painted a gruesome picture of Basilosaurus's hunting habits. Numerous Dorudon skeletons show signs of catastrophic damage to their skulls, with deep punctures that match the teeth of Basilosaurus. These injuries suggest that Basilosaurus hunted its fellow whales by delivering powerful bites to the head, effectively crushing their skulls. After inflicting these fatal injuries, it likely tore apart its prey for consumption. The presence of both large canines and robust molars supports the idea that Basilosaurus could both pierce and tear its prey, making it an incredibly efficient predator. Even more chilling is the discovery of stomach contents within certain Basilosaurus fossils. These rare finds have provided direct evidence of its diet, revealing that it frequently consumed sharks, including early relatives of the fearsome Megalodon. The fact that Basilosaurus preyed on sharks adds another layer of complexity to its role as an apex predator. It wasn't merely a large passive whale. It was an active hunter, capable of taking down some of the most fearsome creatures of its time. This dietary evidence underscores just how formidable Basilosaurus was in its environment. It was not restricted to hunting a single type of prey, but instead had the flexibility and power to pursue a wide range of targets, from large fish to other marine mammals. This versatility would have given it a significant advantage, allowing it to adapt to different prey populations and environmental conditions. Such adaptability is a hallmark of successful apex predators, and Basilosaurus was no exception. The dominance of Basilosaurus in its ancient environment is a testament to its specialized adaptations and hunting strategies. Its massive size, powerful jaws, and varied diet made it the undisputed ruler of the shallow seas it inhabited. Yet, unlike modern whales, which often live in groups and display social behaviors, Basilosaurus was likely a solitary hunter, patrolling its territory and ambushing prey with bursts of speed. Its streamlined, narrow body allowed it to move swiftly through the water, despite lacking the large tail fluke seen in modern cetaceans. Instead, it swam in an undulating motion, similar to that of an eel or snake, giving it an eerie, wave-like movement through the water. This combination of traits made Basilosaurus a nightmare for its prey, which faced the constant threat of a silent, stealthy hunter with a bone-crushing bite. The seas of the Eocene epoch were undoubtedly a dangerous place, and at the top of this ancient food chain stood Basilosaurus, a whale unlike any that exists today. One of the most startling revelations about Basilosaurus emerged not only from its extraordinary size and predatory habits, but also from the unexpected locations in which its fossils were found. Perhaps the most surprising among these was the Sahara Desert, now an arid, sandy expanse that seems entirely disconnected from the oceanic world. Yet millions of years ago, during the Eocene epoch, the Sahara was a vastly different landscape, shaped by ancient seas and lush coastal environments. The discovery of Basilosaurus fossils in what is today the Valley of Whales, or Wadi al-Hitan in Egypt, has provided key insights into the dramatic transformations of Earth's environments and the life forms that adapted to these changing worlds. The Valley of Whales, located about 200 kilometers from the current Mediterranean coastline, was once submerged under a shallow sea, forming an ideal habitat for marine life. During the Eocene, which spanned from approximately 56 to 33 million years ago, the region that is now the Sahara was a warm, shallow marine environment teeming with a diversity of life. It was in this setting that Basilosaurus roamed as a dominant predator. The sea was filled with various fish, sharks, and early marine mammals, and the coasts were fringed with mangrove forests and other coastal habitats that served as crucial ecosystems for numerous species. The fossils found in Wadi al-Hitan are extraordinarily well preserved, offering scientists a detailed look at the ancient life that once flourished in these waters. The first fossils of Basilosaurus discovered here astonished paleontologists who unearthed complete skeletons of these ancient whales. These fossils, which included both Basilosaurus and other marine creatures like Dorudon, presented a rich tableau of life during the Eocene epoch. The sheer number and condition of the fossils indicated that this region was once a thriving coastal ecosystem and not the barren desert it is today. This ancient sea, which covered much of North Africa during the Eocene, was part of a vast network of shallow, warm waters that connected different parts of the world. It's believed that these waters were not only warm, but also nutrient-rich, fostering a highly productive marine environment. Such conditions would have attracted a wide variety of marine species, from large bony fish to early cetaceans like Basilosaurus. These warm seas served as critical migration and feeding grounds, and their coastal areas likely provided ideal breeding habitats for these early whales. The presence of Basilosaurus in these waters highlights how this whale adapted to and dominated its environment. Unlike modern whales, which can often venture into deeper waters, Basilosaurus was limited to the shallow coastal seas. Its buoyant body and inability to perform deep dives meant that it had to remain near the surface. The fossil evidence from Wadi al-Hitan suggests that Basilosaurus thrived in these relatively shallow environments where it could easily ambush prey and patrol its territory. This shallow water lifestyle, combined with its specialized hunting techniques and powerful jaws, made Basilosaurus a perfect fit for its ancient habitat. One of the most intriguing aspects of Basilosaurus's presence in Wadi al-Hitan is the glimpse it offers into the region's ancient climate and geography. The fossils in this valley reveal that the Sahara was once a lush, watery expanse, a stark contrast to its current state. Researchers have found evidence of a diverse array of marine life in these ancient seas, ranging from large predatory fish to early relatives of modern sirenians like manatees and even turtles. The coastal ecosystems of the time likely included mangrove forests or similar wetland habitats, which would have provided important breeding and feeding grounds for numerous species, including Basilosaurus. However, recent studies have raised questions about the long-held belief that the area around Wadi al-Hitan was primarily a mangrove forest. Paleontologists once believed that fossilized root structures found in the area were remnants of ancient mangroves, but further analysis revealed that these structures were actually burrows made by an unknown terrestrial or semi-aquatic creature. This revelation has prompted scientists to reconsider the exact nature of the coastal environment that Basilosaurus inhabited. It's possible that rather than a dense mangrove forest, the region may have been a broader coastal ecosystem with shallow, warm waters, tidal flats, and other coastal features conducive to marine life. Despite these uncertainties, the fossils from Wadi al-Hitan clearly indicate that Basilosaurus played a crucial role in its ecosystem. The abundance of fossils suggests that this area may have been a key habitat for these ancient whales, perhaps serving as a breeding ground or hunting territory. The large number of Basilosaurus remains found in the valley indicates that these creatures were not only highly successful, but also widespread within their range. In addition to Basilosaurus, the fossil record in Wadi al-Hitan has yielded evidence of other early cetaceans, including smaller whales like Dorodon. The presence of these smaller whales alongside Basilosaurus provides further insight into the predatory dynamics of the time. Dorodon fossils often bear the marks of violent encounters, with injuries consistent with Basilosaurus attacks. This evidence of interspecies predation illustrates the complex web of life in the ancient seas, where Basilosaurus ruled as the top predator. The discovery of Basilosaurus fossils in Wadi al-Hitan has not only deepened our understanding of this ancient whale, but also shed light on the broader history of the region. The transition from a lush, shallow sea to an arid desert is a powerful reminder of the dramatic changes that have shaped Earth's landscapes over millions of years. As the climate shifted and the seas retreated, the once thriving marine habitats of the Sahara gave way to the vast, dry expanse we see today. These changes were driven by tectonic shifts, fluctuations in sea levels, and broader climatic shifts that reshaped the entire region. Beyond Wadi al-Hitan, Basilosaurus fossils have been found in other locations around the world, including the United States, Jordan, Tunisia, and Pakistan. These widespread discoveries suggest that Basilosaurus had a broad range and was highly adaptable, thriving in various coastal environments. This wide distribution also indicates that the shallow seas of the Eocene were interconnected, allowing marine species to migrate and spread across vast distances. The presence of Basilosaurus in such diverse locations demonstrates its success as a species and its ability to dominate different marine ecosystems. The fossils of Basilosaurus in the Sahara are not just relics of an ancient predator, they are a window into a lost world. They offer a glimpse of a time when the Sahara was a thriving coastal environment, teeming with life and dominated by one of the earliest giant whales. The story of Basilosaurus in the Sahara is a reminder of the ever-changing nature of our planet and the adaptability of life in the face of these changes. As paleontologists continue to study the fossils of Wadi al-Hitan and other ancient sites, they uncover new details about the lives of these ancient creatures and the environments they inhabited. The significance of the Valley of Whales extends beyond its paleontological treasures. It serves as a testament to the immense geological and climatic shifts that have shaped our world over millions of years. From the lush, shallow seas of the Eocene to the arid deserts of today, the story of Wadi al-Hitan and its ancient inhabitants like Basilosaurus reflects the complex interplay between life and the environment. This unique fossil site stands as a reminder of how even the most seemingly inhospitable places were once home to thriving ecosystems and colossal predators like Basilosaurus. The anatomy of Basilosaurus presents a captivating snapshot of whale evolution during a crucial period when ancient cetaceans transitioned from a semi-aquatic lifestyle to becoming fully adapted marine creatures. Unlike modern whales, which are sleek and streamlined with no visible traces of their terrestrial origins, Basilosaurus retained vestiges of its evolutionary past. Most strikingly, this massive predator still possessed small hind limbs, a reminder of the time when its distant ancestors walked on land. These remnants of legs were perhaps one of the most peculiar features of Basilosaurus, hinting at the transitional journey of early whales. The hind limbs of Basilosaurus were not functional in terms of locomotion. They were greatly reduced in size and had a strange, almost vestigial appearance, measuring just a little over a foot in length. Each limb consisted of a small but well-formed femur, tibia, and fibula, along with minute toes at the end. Given the whale's massive size, these tiny legs would have been almost invisible to an observer, tucked along the sides of its long, serpentine body. Yet, their presence is a significant clue in understanding the evolutionary path of whales. The hind limbs likely had no real role in propulsion or swimming, as Basilosaurus relied instead on its powerful body and tail for movement. The small size and reduced musculature of these limbs made them ill-suited for any kind of locomotion on land or in water. Despite their lack of a clear function, some paleontologists have suggested that these tiny hind limbs may have been used during mating. The idea is that they served as stabilizers or guides, helping Basilosaurus align its long body during reproductive activities. This is speculative, but similar hypotheses have been put forward for other primitive whales with residual limb structures. The hind limbs of Basilosaurus offer an intriguing glimpse into the past, reflecting its descent from land-dwelling ancestors that eventually adapted to a fully aquatic lifestyle. These limbs are not just anatomical oddities, they are key pieces of evidence in the broader story of cetacean evolution. In addition to its hind limbs, the overall body structure of Basilosaurus was quite unique compared to modern whales. While most contemporary whales have relatively short, muscular bodies ending in large, powerful tail flukes, Basilosaurus had a long, narrow body that lacked the prominent flukes seen in its modern relatives. Instead, its tail was relatively weak and thin, which likely meant that it could not generate the same kind of powerful thrusts that modern whales use to propel themselves through the water. This difference in tail structure would have had a significant impact on how Basilosaurus swam. Unlike today's whales, which move their tails in a powerful up and down motion to gain speed, Basilosaurus is believed to have swum in an undulating manner, similar to that of an eel or snake. This unique swimming style involved the creature's entire body moving in a wave-like motion, giving it a somewhat eerie and snake-like appearance in the water. This undulating motion, combined with its long, narrow body, suggests that Basilosaurus was not built for long-distance, high-speed chases. Instead, it likely relied on ambush tactics to catch its prey, lurking near the surface or in shallow waters and using bursts of speed to launch surprise attacks. Its elongated body would have allowed it to maneuver effectively in the complex coastal environments it inhabited, where it could weave between reefs, rocks, and other obstacles to close in on prey. The lack of a powerful tail fluke likely limited its ability to pursue prey over long distances, but this would have been less of a disadvantage in its shallow water habitat. The buoyancy of Basilosaurus was another important aspect of its anatomy that shaped its lifestyle. The vertebrae of Basilosaurus were large and hollow, filled with fluid that made the creature particularly buoyant. This buoyancy meant that Basilosaurus would have stayed near the surface of the water, unable to dive deeply like modern whales. It may have spent much of its life cruising just below the surface, taking advantage of its buoyancy to conserve energy while it patrolled its territory. This preference for shallow waters and surface-level hunting likely influenced its feeding habits and interactions with other marine life. The evolutionary significance of Basilosaurus extends beyond its anatomical features. As one of the earliest fully aquatic whales, Basilosaurus played a crucial role in the story of cetacean evolution. It was a member of a group of early whales known as basilosaurids, which were among the first cetaceans to abandon their ties to the land completely. This group is characterized by several key adaptations to an aquatic lifestyle, including streamlined bodies, powerful jaws and a lack of the large muscular hind limbs seen in their semi-aquatic predecessors. Basilosaurids like Basilosaurus were a pivotal step in the evolutionary journey of whales as they transitioned from semi-aquatic animals to true marine mammals. The transition of whales from land to sea is one of the most remarkable evolutionary events in Earth's history. Early cetaceans, known as Archaeocetes, started as land-dwelling mammals with hooves and legs adapted for walking. Over millions of years, these creatures gradually adapted to life in the water, first becoming proficient swimmers and then losing their hind limbs altogether. This evolutionary journey involved numerous anatomical changes, from the development of powerful tails and flukes to modifications in the structure of their skulls and ears that allowed them to hear underwater. Basilosaurus is a key piece of this evolutionary puzzle, providing crucial evidence of how early whales made this dramatic transition. However, despite its adaptations and dominance in the shallow seas of the Eocene, Basilosaurus's reign was not destined to last. The end of the Eocene epoch was marked by a series of dramatic environmental changes that would bring an end to this ancient predator's dominance. The Eocene-Oligocene extinction event, which occurred around 33 million years ago, was one of the most significant extinction events since the demise of the non-avian dinosaurs. During this period, Earth underwent a series of climatic shifts that drastically altered the planet's ecosystems and wiped out a large number of marine and terrestrial species. The exact cause of the Eocene-Oligocene extinction event remains a topic of debate among scientists. Some researchers believe that the event was triggered by a major glaciation event, which caused sea levels to drop and temperatures to cool significantly. This would have had a profound impact on marine habitats, particularly the shallow coastal waters that Basilosaurus inhabited. The drop in sea levels would have reduced the availability of suitable habitats for these ancient whales, while the cooler temperatures could have disrupted their food supply and reproductive patterns. Other scientists suggest that the extinction event may have been caused by a large asteroid or comet impact, similar to the event that led to the extinction of the dinosaurs. Such an impact would have created massive tsunamis and released large amounts of debris into the atmosphere, blocking out sunlight and causing a dramatic cooling of the Earth's climate. This sudden shift in environmental conditions would have been catastrophic for many marine species, particularly those that relied on stable, warm water habitats like Basilosaurus. Regardless of the exact cause, the impact of the Eocene-Oligocene extinction event on marine life was profound. It led to the extinction of many early whale species, including all members of the Basilosaurid family. Basilosaurus, once the undisputed apex predator of its environment, was unable to survive the dramatic changes in its habitat. The extinction of Basilosaurus marked the end of an era as the ancient seas of the Eocene gave way to the cooler, more modern oceans of the Oligocene. While Basilosaurus and its relatives perished, the extinction event also paved the way for the rise of a new group of whales, the Neocetes, or modern whales. This group, which includes today's baleen whales and toothed whales, emerged and diversified in the aftermath of the extinction event. Neocetes were better adapted to the changing environmental conditions with new anatomical features that allowed them to thrive in a wider range of habitats. The extinction of Basilosaurus and the rise of Neocetes reflect the dynamic nature of evolution, as species adapt to changing environments and new niches are filled by different forms of life. Although Basilosaurus vanished from the seas, its legacy lives on in the fossils that continue to be unearthed in places like the Sahara and the Gulf Coast of the United States. These fossils provide a glimpse into a world that was both familiar and alien, a world of warm, shallow seas ruled by a giant serpentine whale with powerful jaws and a fearsome bite. The story of Basilosaurus serves as a reminder of the incredible diversity of life that once existed on our planet and the constant changes that shape the course of evolution. Today, Basilosaurus stands as a symbol of both the ferocity and adaptability of early whales. Its fossils tell a story of survival, dominance, and ultimately, extinction in a rapidly changing world. As scientists continue to study Basilosaurus and its relatives, they gain new insights into the evolutionary history of whales and the ancient environments they once inhabited. The tale of Basilosaurus is a powerful testament to the resilience of life and the constant march of evolution. A story that continues to captivate and inspire those who seek to understand the ancient oceans and the creatures that ruled them millions of years ago.